Hi, everyone, and welcome to this session on Kubernetes native policy management with Kiverno. The topics we will cover today is why policies matter for Kubernetes, why Kiverno is a native policy management solution that you should consider. We'll also go deeper into how Kiverno works for Kubernetes, what Kiverno policies look like, and what features Kiverno offers. And then we'll do a quick summary and we'll also do some demos along the way. So just in terms of a quick introduction, I'm Jim Bugwadia. I'm a co-founder and the CEO at Nirmata. Nirmata is a company that makes Kubernetes management, security, and automation tools. I'm also a Kyverno maintainer. Kyverno is a CNCF sandbox project. Nirmata donated Kyverno to CNCF in November of 2020, and I'll talk about some of the growth and successes we're having with the community since then. I also serve as a co-chair of the Kubernetes Policy Working Group, and I'm a lead with the multi-tenancy working group in the Kubernetes community. All right, so let's dive in. The first topic I want to introduce is why policies matter to Kubernetes itself, right? Kubernetes, of course, is a very powerful and complete system. And as we know, more and more enterprises are adopting Kubernetes today for all sorts of applications, whether it's on cloud, data center, or edge computing systems. But in this recent survey from the technical advisory group as part of the Kubernetes community, there's some very interesting findings which also lead to our discussion on why policy management matters for Kubernetes. In this survey, 80% of the folks who answered, and there were about 120 to 130 companies and different enterprises that took the survey, all of them wanted a more modern open source based security system to complement what Kubernetes provides. So almost 60% of the survey answers indicated a lack of expertise as one of the key concerns. Mismatch with existing tooling as another hindrance to cloud native growth and adoption. And then finally, the complexity of management, the complexity of Kubernetes configuration continues to be a major source of pain within enterprises and any organization using Kubernetes. So what can policies do and how do they matter, right? So what I want to show you today is, and demonstrate through Kyverno is that policy-based operations and management can solve each of these key concerns: the lack of expertise, the proper, security by default, and easing the complexity and some of the pain points that folks are seeing with Kubernetes. And I love this tweet from an actual real-world Kubernetes admin, where so obviously somebody who also shares this point of view, who's talking about how without policy management in production clusters, there's disasters waiting to happen. And hopefully by the end of the session, you will share this view as well. All right, so talking about what policies are, and again, how do we think about policy management in addition to Kubernetes, right? So the way I think of it, policies are really a contract between the different roles, between the different type of folks who are using Kubernetes. And if you think about it, in Kubernetes, there's multiple roles. There's developers who are trying to deploy applications. There's the operations team that's trying to manage the clusters, provide some of the shared services. And there's the security or the SecOps team that's trying to make sure that these clusters and the workloads are properly configured, properly secured, and are not going to be, a major source of headlines for the wrong reasons for any situation, right? So all three of these roles have to collaborate on Kubernetes configurations. And because of the way declarative configuration works in Kubernetes, very often it's the same YAML manifest, it's the same declarations that have to be shared and managed across these roles. So policies can serve as a contract, really as a digital and automated contract across these roles to help with coordination of who should do what, how things should be configured in various environments, and what settings need to be defaulted and used, right? So some of the use cases that policies can help address are improve the overall default security, eliminate many of the misconfigurations that are common in Kubernetes environments, provide separation of controls across different roles, right? So developers can focus on what their workload needs, but then security teams can make sure that the proper security defaults, best practices are enforced. And overall, the idea is to reduce the overall complexity because each role that it has expertise in different domains is going to be doing what it knows best and what they can provide best. The other things policy can also do is help automate the various handoffs, which we see with Kubernetes. For example, when a namespace is created, several configurations need to be populated by default. Policy management tools like Giverno, can help automate these. So several use cases and several important concerns that policy management can help address to make Kubernetes secure by default and production ready. All right, so let's talk about, why Kyverno matters and why we built Kyverno for Kubernetes. So first off, in terms of what does Kyverno mean is a common question that we get, right? So Kyverno is a Greek word for govern, and because it provides governance, compliance, security to Kubernetes, we thought it's a good word, term, a good name for a Kubernetes native policy management tool. So if you notice, one of the things I've been saying is Kubernetes native, right? And this often comes across as a buzzword or sometimes as used, in many marketing kind of terminologies to say, everybody wants to be Kubernetes native, right? But for Kiverno and for policy management, it's important to understand what this really means and why being Kubernetes native even matters, right? So the way to think about it is there's several levels in which tools can be Kubernetes native. So first off, it's possible that any tool that works or is designed for Kubernetes can claim to be Kubernetes native. But that's not enough, right? To be Kubernetes native, you really need to be able to talk to the Kubernetes API server, to be able to, understand what some of the objects look like. So that's level two. Beyond that, Kyverno also operates as part of the control plane. As you'll see in the architecture when we talk about this, Kyverno becomes a native part of your Kubernetes installation and interacts with other control plane components. Level four is where Kyverno also understands standard Kubernetes idioms, patterns, things like owner references, pods and pod controllers. And because of this, Kiverno can optimize how policies work and how they should behave in Kubernetes environments. And finally, and this is really critical, is everything in Kubernetes, because of its declarative configuration management, all everything in Kubernetes is all CRs, custom resources, or even native resources are defined using OpenAPI v3 structural schemas. Giverno is intelligent enough to read these schemas at runtime and then to make, to be able to understand what the layout of a Kubernetes object should look like as it applies policies to these objects and resources. So this gives Giverno a very powerful advantage in being able to understand exactly how resources in Kubernetes are structured, what they're, and by the way, this can change from one API version to another. So Kyverno does this dynamically once it's installed and configured in a cluster. So extremely powerful capabilities, which help quite a lot in being able to define policies, write policies, and also Kyverno, when you see how it manages policy results, those are being also managed as Kubernetes resources, which helps the overall experience be very smooth and seamless, and also gives Giverno the policies as well as results to work with any standard tools like kubectl, Kustomize, and other tools that work with Kubernetes APIs. All right, so just to kind of summarize, on why Giverno and what the motivation for driving Giverno was, is to make Kubernetes policies easy to write, easy to manage at scale across a fleet of clusters, making policy results easy to get, not just for the administrators, but the workload owners, right? So developers who want to interact with policies should be able to see what the violations in their workloads are and should be able to react to this as early as possible in their CI/CD pipeline and in their dev, test, and deploy cycles, right? Policies should be able to not just validate and enforce, but policies should be able to promote best practices by mutating, by generating resources as well. And Kiverno is very unique in this area in its ability to generate completely, new resources based on triggers as things are happening in your cluster. And then, a policy engine designed for Kubernetes should support all types of resources, not just the standard resources, but should have knowledge through the OpenAPI v3 structural schema of all Kubernetes resources. And utilize the built-in patterns, practices, the way just Kubernetes controllers work. Giverno and native policy engines should be able to mimic those behaviors as well. So one of the things that also comes up is, okay, so Kyverno sounds interesting, but what are the alternatives, right? And how should you decide what to use? So the two, CNCF projects today, which are policy engines, are Kyverno and OPA Gatekeeper. There's also some other open source projects like Kubewarden, JS Policy, and then there's some other, proprietary admission controllers. Pretty much most security vendors will provide, some admission controllers if they're focused on Kubernetes itself. But the main two, if you're looking at open, flexible, and community-driven tools, the main two that come about are Kiverno and OPA Gatekeeper. And there's some, good research, good comparisons out there between these tools, which I would encourage you to kind of, do some if you just do Google research or, just some quick searches. You will see this is one. By the way, this is a YouTube video by Victor Park at Upbound. He's a developer relations expert over there, and he also helps. He has a very popular YouTube channel where he posts reviews, comparisons, updates on various tools within the open source community. So he's got a great and detailed video comparing OPA Gatekeeper and Kiverno for Kubernetes policy management, which I highly encourage you to take a look at. Also, if you search, there's other blog posts from folks like Chip Zoller at Dell, which go into a detailed comparison of the two solutions as well, which will help you decide on which would be the best solution to meet your needs. All right, so what are the use cases you want to solve and look at with Kiverno, right? So the first and most important use case is pod security, and I'll demonstrate, how that works in action, what you will want to consider when you're looking at pod security for your clusters and for your workloads itself. Other is to make sure that best practices are followed for configuration, even things like making sure that probes for health checks, for liveness checks, all of that is properly configured for your pods and workloads, as well as things like resource quotas. Your role binding should be as granular as possible. Those kind of things can be managed using the fine-grained policies, RBAC policies, available or that are possible with Giverno. Another common use case is to help with namespace-based multi-tenancy. So making sure that when you configure namespaces, all of the right multi-tenant defaults are configured. Now these could be fine-grained roles and permissions, could be resource quotas, limit ranges, network policies, several other objects that need to be configured per namespace. Another pattern which is very powerful is allowing based on namespace labels or based on some other trigger to allow cluster-wide configurations to be automatically created, which this eliminates the need to give extra permissions to namespace owners for cluster-wide resources. Other best practices can be auto labeling of resources, automatically injecting sidecars, certificates or sidecars for logging, monitoring, security, taking advantage of the generate capabilities in Kiverno to be able to do things like automatically generating new configurations on the fly, and even validating image signatures. That's a new use case we have introduced into Kiverno, where you can now easily validate signatures, container image signatures at admission controls using tools like cosign from the 6.4 community, which is another Linux Foundation tool. So lots of use cases and constantly growing in terms of community and like the things that are coming up. With good folks are always bringing new ideas, new things which we can solve with Kiverno. All right, so now let's talk. We talked about why policies matter for Kubernetes, why Kyverno matters, what kind of use cases it can address. But let's dive a little bit deeper into Kyverno's architecture and what this looks like, for your live cluster itself, right? So Giverno works as an admission controller in Kubernetes. And what this means is whenever there's, in Kubernetes, any request, any API request goes through several phases of what's known as admission controls. In fact, let me do this. I'm going to stop sharing the slides and I'm going to actually go to, the Kiverno docs, and we'll take a look at the architecture there, and we'll also kind of install Kiverno onto a test cluster that I have and see it live in. These YAMLs, which are triggered which will then the Kiverno defaults and also kind of install these on our cluster, right? So let's go to installation. And here we go. So the first part of the installation shows how you can install from the Helm chart. But like I said, what we'll do just for simplicity here, I just want to pull down everything from my YAMLs, right? So I'm going to go and say install Kiverno using YAMLs. We'll copy this command and we'll run this on my cluster to see what happens. So at this point, it's gonna, this will take a few seconds, and this command will actually go out, pull down a bunch of YAMLs. Whoops, it says not able to read. So actually, maybe this command, I believe, has just changed in the recent release. So let me go ahead and update this. So this should be configs. So we'll go ahead and try this again. All right, let's try one more thing, which is just config, which is what I believe this directory should be at. And hopefully that works, and we will pull down these YAMLs. If not, we'll try another way of installing. There we go. So now these, the YAMLs are coming down. And as you can see, Kyverno is going to, kind of install some custom resources, as well as, it's going to create a number of default configurations for our YAMLs, right? So if we look at what the installation pulls down over here, we can see, let me make this a little bit bigger so it's visible. The installation will, pull down a bunch of, resources in the cluster itself. So let's go ahead and see. I think there's a picture here somewhere. Let's go back to the installation section. Yeah, so this is showing the different kinds of installation. And then in here, this is the picture I was looking for, which shows how the Kyverno deployment, the service, the pod gets created. And once Kyverno is up and running, it will automatically create, other configurations like a validating and mutating webhook configuration, some cluster roles, role bindings, things like that, right? So all of this, and even the certificates necessary for Kyverno are automatically managed. All right, so let's go ahead and, now that this is done, let's see what this, looks like. So if we do kubectl get namespace, we will see that in, my cluster, in my minikube cluster, now I have the Kiverno namespace. And if I do -n Kiverno and do get, pods, I should see there's a pod running, which is still initializing. And if I also do, we can kind of look at the logs for the pod, of course. So if we do logs, deployment Kyverno, once that pod is up and running, we'll see, some logs come out and Kyverno should be ready, right? So we see here Kyverno actually came up. It does a leader election. So a leader election will make sure that if there's multiple instances of Kyverno running, some of the responsibilities are shared. So you can run Kyverno in an HA manner. And now Kyverno is up and running. But at this point, even though I have Kyverno running, I don't have any policies configured, right? So what I want to show you is what happens in Kubernetes if you're running without pod security. And this is a very important thing to understand in terms of how containers and pods work on Kubernetes. I'm going to run a command which is going to actually, run something which an attacker or somebody who's trying to, let's say, get access to your cluster can potentially do. So in this case, this command and the person doing this only has privileges to run pods within the cluster itself, right? So they don't have, permissions necessarily to run other things. But because we haven't set proper security, Kubernetes by default does not block pods from looking, getting into the privilege mode. They do not block pods from running as root user. So things like that are allowed, right? So when I run this command in my cluster, what I'm seeing is it's going to take a few seconds, but it's actually going to bring up a pod. It's going to, replace its configuration to actually make sure that, privileged is set to true in the configuration. And then it's going to do an NS enter and actually, mount, proc1, from there, right? So interestingly, so now I see I have a bash shell, which this pod gave me. And if I do, go to, slash, I do an ls, I have access to pretty much all of my host file systems at this point. If I go to proc, and let's see what we find over there and what we have visibility to, if we're even allowed to do this. So as you see by default now, I'm in here, I can kind of list everything, and I have pretty much access to, this cluster. And just to make sure that we are root, if I do who am I, over here, it's telling me I'm running as root, right? So certainly not good from a security point of view, because anybody who can run a pod in this case is now able to, get to run that pod get access to the host file system, or run a pod with privileges, which can get access to the host file system. And from there, even get to things like if I go to etc Kubernetes, this is where the Kubernetes installation files are. This is where I can get to the secrets for my cluster, including the certificates, the root CA, and things like that used. And of course, I can get access to more advanced things from here, right? So what do we do, and how do we prevent this? So let's exit out of this pod and see what we can do with Giverno itself. So I'm going to go ahead and delete this pod because we'll try to run this command again later. So let's go ahead and clean up. Let me get that command right. So we just want to delete this pod, which we ran, which got root access. And then what we're going to do is I'm going to install some pod security policies, which should help us, kind of promote, again, best practices and help prevent this from happening, right? So going back to the Caverno, website, what I want to look for here is actually I'm going to go to the policies library. And in this case, we're going to see a bunch of default policies. What I want to select is pod security. And in here, so if I go to pod security, just click on that. It will show me my default pod security policies. And by the way, in Kubernetes, there's something called pod security standards, which define the default set of policies which are recommended. There's two levels, there's baseline and privilege. But what we're going to do in this case is we're just going to copy again this command, which can install all pod security policies and which will also kind of put things in enforce mode into our cluster, right? So let's copy that command and let's go back to our shell and we'll try and run this command, which is going to pull down. So what this is doing is it's first going to call customize on this repo, which is grabbing some policies from the Kiverno repo for pod security. And then it's going to just do pipe them to kubectl and do an apply minus F, right? In a few seconds, we will see that all 15 of these policies, if we go back while this is happening, we can go back to the web page and kind of browse pod security policies. Most of these policies will get installed, or all of these will get installed, and they will get installed with enforce mode onto our cluster itself. So we see now these are getting installed. And okay, so let's now do a kubectl. Oops, I keep misspelling this. So I'm going to do a get cpol. So and cpol is just a short name for cluster policies, which will show us, all of the policies which are installed in our cluster. So we see that we have all of these pod security policies. And the other thing you can see is some of them are saying ready and the others are not saying ready, right? So what happens is when Kyverno installs these policies, it will automatically update your webhook configurations with these policies and make sure that the webhook is configured to allow all of the operations that these policies require. So we'll give it a few seconds and so now all of these policies are ready, and we should be good in terms of at least making sure that we have default pod security configured into our cluster, right? So what does this mean? So let's go ahead and now again try that same command again. Um, so we'll do kubectl and we'll do run. And this was the command which let us run as root. So if I run this again in my cluster, what I would expect at this point is that Giverno is going to block these and reject that pod from running, right? And sure enough, so now what we see is there's several policies which got violated. It's saying, hey, you cannot run using the host namespace. That's of course one of the ways to get access to host resources. You cannot run a pod as privilege mode, so you cannot mount certain privileged ports. You cannot get to other file systems, and you cannot run as root, right? So all of these things are now being prevented by default, just by installing these basic set of policies. So certainly pod security is a very important use case. And if you don't have pod security configured, I would highly recommend that you use either Kyverno or other ways of configuring pod security and making sure this is properly enforced on your clusters, right? All right, so let's go back to the presentation and we'll kind of, we already covered some of this of how Kyverno works, what it can do within that, but what else can we do with Kyverno policies? And we'll now go deeper into some of the policy definitions, what those look like and what you can do. So every policy in Giverno has this basic structure, right? So a policy is a set of rules, and rules can match resources, exclude resources, and then once you select which resources you want the policy to operate on, then you can mutate, verify images, validate resources, or generate resources. When you validate resources, Kiverno can either block and enforce that policy, or it can allow that configuration based on your setting and later report a violation for that particular policy. So a lot of flexibility, and this makes it easy to roll out Kyverno into your production cluster without impacting any existing workload. So this is an example of a very simple policy, which is just checking and enforcing that a particular label, in this case, app Kubernetes IO/name. So a best practice is to label all workloads and give them a name. So it's enforcing that this policy is set or this label is set on every pod. Now, one interesting thing with Kiverno is because, again, of it being Kubernetes native, when you write a policy in a pod, that policy is automatically applied to all pod controllers, even non-standard, even custom pod controllers, like if you have an Argo deployment or other things, those can also work with Kyverno policies very easily. And you don't have to write policies on every pod controller, but Kyverno does all of that heavy lifting underneath the covers for you. So this is another example of a policy. And as you know, in Kubernetes, several things get, deprecated over different versions. So one of the things that's happening is there have been several API objects marked for deprecation. And with 1.25, these objects will actually be removed. So how do you know in your clusters who's using those and how do you inform them, right? So Kyverno can solve that problem for you using this very simple policy. What it will do is now it will be able to detect and see that if anyone's using these resources, it can create a policy violation, and those violations will show up even in the namespace that that user has. And through external management tools like what Nirmata provides and other companies provide, you can even send alerts, notifications. You can kind of inform those. In fact, some features also allow you to create Jira tickets and things like that for the appropriate owners, right? So very simple to write, but very powerful in what it can do. Other policies can actually mutate configurations. So this is a very simple example of mutating a pod configuration again, and just based on the port, being able to default things to a port number. But you can even do very complex mutations through Kyverno using either the JSON patch syntax, which is based on an RFC, or you can also use a patch strategic merge, which again is very native to Kubernetes. The Kubernetes API server supports a strategic merge patch, and Kyverno fully supports that as well to be able to merge various types of Kubernetes objects based on their schema definitions. The other type of policy in Kyverno is a generate policy. And what this is good for is to automatically create default resources, or even to create cluster-wide resources based on a change in a configuration or based on when some other resources are created. The most common example, again, is when a namespace is created. You can then trigger automatic configurations for that namespace. Another example is when someone creates a label on a service or a label on a namespace. You can use that now to create some cluster-wide configuration for that. Maybe it's an Istio policy, things like that, automatically within your cluster, right? So there's several, very interesting use cases and ideas coming up in the community. And certainly we expand the library that I showed with policies. We're constantly adding, best practice and these type of examples there as well for, the community. A new kind of policy we just introduced in Kyverno 1.4 is image verification policy. So today, of course, you may have heard a lot of these headlines and some of these stories about supply chain security and why that has become such an important, thing to pay attention to within your overall security, strategy, as well as, the posture of your overall systems, right? So more and more attackers are kind of, using CI/CD systems as the point of entry. And it's really important to know that what you're deploying in your cluster is validated, trusted, and can be, is actually the container or the image that you think it is. So today, if you pull an image, whether it's by tag or by digest, really you don't know if something can intercept that request and can maybe there's a different image that is trying to use the same tag or uses the same name, and it can impersonate the image that you are expecting to get. Or even if it's a third party image, you don't know if that was actually signed, scanned, validated, and is ready to be deployed into a production cluster. So by signing images, you can get some basic security in place to be able to make sure that only images signed by your private keys are the ones that are defined. And this policy again is a very simple example of how you can use a single key, but Kiverno supports multiple keys. One of the new features we've added in 1.5 is to support attestations. So attestations are signed metadata, which can even do things like for your vulnerability scans, for your code reviews, other things that you want to enforce for production. Now you have the ability to make sure that those settings are in place before somebody deploys something in your production cluster. All right, so those are the types of policies that are available in Giverno. But let's kind of now, switch to some more advanced features. Because one of the things that comes up is, like some other policy engines like OPA, Gatekeeper, they offer a full programming language, right? So are there things that are limited in Giverno? What can Giverno not do? And what I want to show is that Giverno is very capable of writing some complex and powerful policies, and there are several samples that we have in our, community library, but here I want to showcase the features that allow these complex policies to be written. So the first thing that's required is variables, right? Because you don't want to write policies from scratch and you want to augment policies with data coming in real time from the cluster or other data sources, right? So in Kyverno, you can, have variables can either reference other parts of a policy, or you can use variables to extract data from your admission request, which is sent by the API server. So in this second example, we're looking at request user info, username. So this can come from the API server. And Kyverno automatically, builds a context which you can use with, any of your policies with a rich set of data and built-in variables itself. So the other thing that is very powerful in Kyverno is these variables can be, used James path or JMES path type expressions, which can make it very easy to, run even certain functions, other things, for your, on your variable data itself. So if you want to do comparisons, if you want to extract information, even run regular expressions, all of that is very easily available. Now, what you can start doing is you can even now combine this with external data that Kyverno allows. And there's three data sources that Kyverno allows: config maps, which are supported natively, again, as being part of Kubernetes; API server lookups, which can pull information from the API server; and OCI registry lookups, which is how Kyverno does things like image signature and image attestation verification, right? So here's an example of a config map. And as you can see, it's very easy now to define a config map. And once that config map is defined, you can declaratively say you can pull data from that config map into your policy and make some policy decision. One great example of this is restricting workload identities. So once a image uses a particular secret, making sure that no other image or no other pod can mount that secret, and it's only assigned to that particular image, right? So things like that you can do with external data. Beyond that, also you can do API server lookups. And this is maybe a little bit hard to read, but there's again examples on our website where what this is doing is making sure that, it's counting the number of load balancer services in a namespace and it's restricting that to one. So what that, involves is making an API server call if somebody is trying to create a new service. And if the type happens to be load balancer, the API call that's made is to get other load balancer services in that namespace, and then being able to make sure that the length of that is stored in a variable, which can then be enforced to say that it has to be, it cannot, if it's greater than or equals, the one already, then you deny that request, right? So extremely powerful policy, and you can see how easy it is to kind of read, manage, and write without getting into other complex programming kind of requirements, but you following, standard using standard tools and following Kubernetes best practices itself. Um, the other, kind of example, that again here I don't have a screenshot for a policy sample, but this is again available in our library. So for external OCI registry lookup, this is used for querying image signatures, attestations, completely supports private registries, and you can even look up things from multiple registries based on your requirements or based on how you have things configured. Some other features in Kyverno I want to quickly cover, and then we'll wrap up and summarize, is Kyverno has native policy reports. So reports themselves are Kubernetes resources. Here, this is an example of a namespace-based report. It's showing the pass, fail, and things like that. And you can, of course, use kubectl to get this, or you can use external tools, any of your management tools that are getting reports or can manage Kubernetes resources to be able to see this, right? There's also a graphical tool available called Policy Reporter. This was written by one of our community members, Frank Jogile, and he has open sourced this and donated it to the Kiverno project, where this gives you a graphical view of all your violations, all of your policies, and it can also send notifications to different tools like Slack or Teams or even Discord, and things like Elasticsearch if needed for your upstream monitoring and logging tools. There's also, Prometheus metrics available by default. So Kiverno will produce, several metrics for policy application, policy rules, execution, latency, things like that. And there's a Grafana dashboard which you can leverage to be able to view all of this for your clusters as well. Now, of course, again, external monitoring and management tools like what Nirmata provides and others provide can provide a multi-cluster view, leveraging some of this information that Kyverno is producing. Finally, one thing also to mention is the Kyverno CLI. And this is a very powerful tool for testing policies, writing test cases for policies, and even applying policies as part of your CI/CD pipeline. So there's already GitHub Actions available. There's other things available to easily apply multiple policies, to your cluster, or to locally apply policies to a set of YAML resources, and generate policy reports from it, which you can use in your GitOps pipeline or your CI/CD actions to be able to immediately warn users of any violations or anything that they might face, right? So very powerful set of tools available. All right, so let's just quickly summarize, and see, like we covered a lot of things, and just to kind of wrap up and kind of see what Kiverno provides, why it's interesting, and we'll talk about how you can get involved in the community and how you can also quickly try this out in your clusters. So in summary, Kiverno is a policy engine designed for Kubernetes. Like we talked about, policies can help address some of the key concerns around the complexity of Kubernetes, automating security, and making security a shared, collaborative experience within these clusters. Giverno not only can block and enforce, but is also useful for generating resources, which makes it extremely powerful and useful. And it's simple to get started with. If you know Kubernetes, if you've kind of invested in Kubernetes, Giverno is very easy to get started with without any additional learning curve. We have a very active community. Several, we have about like 85 plus contributors, and this is growing fast. We have multiple maintainers from different companies, and there's a very good set of docs, sample policies, things like that, all available at Caverno.io. In the Kubernetes workspace, we have a Slack channel, which is just called Kiverno. So feel free to stop by the Slack channel, say hello. I'm pretty active over there, so you can always look me up and reach out over there. And then we also have weekly contributor meetings and monthly community meetings for end users, right? So everybody's welcome to join these meetings, just listen in or bring up your use cases and questions, right? So we're always looking for more use cases, things to solve, and how we can help make Kubernetes a more secure and more automated, as well as a smoother experience for new users, right? Finally, one quick thing to mention, if you go to learn.nirmata.com, there's a new Kiverno certification offered through Nirmata. So feel free to try that out. It's a fun way to kind of test your knowledge of Kiverno, as well as get a badge. If it's when you once you get certified, this is something that you can kind of get and share with your community as well as on your social media profiles. All right, so those are all of the things I wanted to cover. I know we went through quite a lot, but thank you again for attending, and hopefully you will give Kyverno a try for your Kubernetes clusters. And certainly, as I mentioned before, please reach out if you have any thoughts, questions, feedback, or just want to say hello and kind of share your experience with Kyverno. Thank you. Bye-bye.